Hello. In this video, I'm going to take a look and talk about imaginary numbers and complex numbers. This whole chapter, chapter 3, looks at working with quadratic equations or equations that involve an x squared. Okay. And so in doing this, we're going to run into some situations where we need to use imaginary numbers. Imaginary numbers are when I have a square root with a negative number inside of it. And so the way that mathematicians handle this is they define I to be the square root of -1. That means if you square it, I squared then is the square root of -1 squared, which these are inverses of each other, and so they cancel out, and we're left with I squared equals -1. The way we use this, if you look down here, if you think of this as the square root of -1 times the square root of 4, times the square root of 16, you can see that this square root of -1 becomes I. The square root of 16 is 4. Usually we switch it around and write it as 4I. And what that means is 4 times the square root of -1. Alright, so B here then, we can break this up. Square root of -1 times the square root of 7. That's I times the square root of 7. Throughout this video, I'm going to leave some problems for you to do, and I'll show you the solutions to those at the end of the video. So I'm going to leave C and D for now. So imaginary number is a number that has an I, or the square root of -1. A complex number is a number that has this form, A plus BI. And in that case, A and B are real numbers, and A is the real part, BI is the imaginary part. So if you look here, if I have a number 8 plus 6i, you can see the 8 is the A, the 6 is the B. This is a complex number, and so I'm actually going to do part B for now, because subtraction's a little bit more tricky. I think if you pause this, you'd probably be able to do this on your own. What we need to do is distribute that negative sign, and then just combine like terms. So that gives me 4 minus 6, that's -2, and then 5i and 3i gives me 8i. And so that's how I would subtract two imaginary numbers. Let's take a look at multiplication. Normally when we multiply two square roots, we can just multiply them together, as you see here. However, this isn't true when the square root of an A and square root of B are not real numbers. When they're imaginary, we have to deal with the I separately. And so that's just what we're going to do here. Okay. We're going to take this as the square root of -1 times the square root of 16 times the square root of -1 times the square root of 25. This gives me I times 4 times I times 5. I just took the square roots there. You can see we get, and really you might just look at it here and realize that this is going to be squared. But this becomes I squared times 20. But I squared is equal to, if you'll remember, just -1. And so this becomes -20. Okay. Questions there? Let's take a look at part D, and I'll leave B, C, and E for you. To square something means to take it times itself. And so now I just treat this like any binomial expression. I multiply the 3 and distribute that out, and then I distribute the -7i. So that's going to give me 9 minus, uh-oh, I was going to leave this for you to do. Sorry. Was that all I was going to do? E. I was going to do E. That's what I was going to do. Sorry. So distribute E here. Distribute the 5. Distribute the 2i. This is kind of cool. If you watch, you see 5 times 5 is 25. 5 times negative 2i gives me the negative 10i. And then 2i times 5 gives me positive 10i. And 2i times negative 2i gives me negative 4i squared. You'll notice these like terms here are opposites. Negative 10 plus 10 gives me 0. I'm left with 25 minus 4 times I squared. But you remember I squared equals negative 1. And so we end up with 25 plus 4, which is 29. So whenever we have this scenario where we have a positive and then the opposite here with the plus 2i minus 2i, these middle terms cancel and I end up with a real number instead of a complex number. These are called conjugates of each other. Okay, so the conjugate of a complex number, a plus bi, is a minus bi. These are called complex conjugates. So if I have 14 minus 5i, what's the conjugate? If you said 14 plus 5i, you're right. How about 8i? What's the conjugate of 8i? Well, if you notice, this is the imaginary part. If I put 0 in front of it, you can think of this as 0 minus 8i. So 8i and negative 8i are conjugates. All right, this last section here is on simplifying powers of I. How could I simplify I to the 37th power? If you think back, we're going to start with a few key ideas. You know that I is the square root of negative 1. You know I squared, if you square that, is just negative 1. If you follow this pattern out, I'm confident you can simplify I to the 37th on your own. Give it a try if you'd like. I've written some things out over here that I'd like to show you. So if you take a look here, I have I to the first power. That kind of looks like negative 1, but it's supposed to be I to the first power. I to the second power, we've already talked about that. If you look at I to the third power here, that's the same as I squared times I. I think you would agree with that, right? So I squared we know is negative 1. I is just I, so this becomes negative 1 times I, which is negative I. I to the fourth then, you'd agree is I squared times I squared, which is just negative 1 times negative 1, which is positive 1. And this is really great. This pattern is going to repeat. Okay, if you look here at I to the fifth, I can break that into I and I to the fourth. Well, we know I to the fourth is 1, and that's really good, because now that I'm just left with I. And you see that's what I got up here. I to the sixth, then, we can break it to I squared, I to the fourth. That gives me I squared times 1, because we know I to the fourth is 1. And I to the squared is negative 1. So I to the sixth equals negative 1. You see the pattern repeating here? All right, here we've got I to the seventh. We can break it apart. We can reduce it to I cubed, which is the same as negative I. And I to the eighth, now we have 2 I to the fourth. That gives me 1. Okay. Now, there's a lot of ways to think about this, and I'd encourage you to do whatever makes the most sense to you. But I think students kind of like this strategy. If you take the exponent and divide it by 4, you'll see another pattern. 1 divided by 4, 2 divided by 4, 3 divided by 4, 4 divided by 4, 5 divided by 4, and so on. You notice you get these decimals: quarter, half, 3/4, 1, 1.25, 1.5, 1.75, 2.0. Again, we've got some repeating patterns here. You see that? Every fourth one. And I won't highlight all these just for sake of time. So back to the original here. If I take I to the 37th over here, and I would take 37 divided by 4, that's going to give me 9.25. And just from that, you can see that that's going to reduce down. It's this 0.25 that I'm looking at. Every time it ends in 0.25, it's going to reduce to I. So if you like that method and it makes sense to you, you can just say equals I, and you can be done. I'll show you another way that you can think about this. If I to the 37 divided by 4 gives you 9, that means I to the 4th to the 9th power, that's going to give you I to the 36, and one more I. That gives you I to the 37th. Now, I to the 4th we know is 1. 1 to the 9th times I. 1 to the 9th is just 1 times I is just I. You see, either way we get the same answer. Alright, let's try I to the 58. If you were to take 58 divided by 4, I kind of want to do that off to the, just zoom in. 58 divided by 4 would be 14.5. So you see that 0.5 using this chart over here. Anytime I ended in 0.5, that tells me I have an I squared left. That's going to be -1. So I can see that this is equal to -1. If you like to see why that's true, we can do I to the 4th to the 14th power. That's going to give me 56 i's times I squared. This becomes 1. I'm left with I squared. 1 times I squared. I'll write it out for you. Equals -1. All right. So that concludes this section. Feel free to pause the video and work through the problems that I didn't do. And I'm going to go through and show you the solutions now. Here's one on adding. Multiplication here. Another multiplication. Squaring. And a couple here simplifying. And that concludes this video.